Hey everybody, here are some notes for the second day of hyperbolas. Since we already learned about some of the key features of hyperbolas, we're just going to do a couple of examples that will hopefully be helpful. So the first example wants us to write an equation of a hyperbola that has a conjugate axis length of 6 and vertices at 3, 4, and 3, 0. Since I don't know where to put the conjugate axis, I'm going to start by plotting the points at 3, 4, and 3, 0. And doing so allows me to see where the center of my hyperbola would be. Since I know where the center is, I will also know where to put the conjugate axis. So my vertices are vertical from each other. That means that the transverse axis will be spanning the distance between them. And then perpendicular to that, through the center point, my conjugate axis has to span a length of 6, so it goes 3 to each side of my center. Having that information is actually all the information I need in order to write the equation for this hyperbola. First off, since the vertices are the point that the graph passes through, I know that this hyperbola is going to open up and down rather than side to side. And so that means that I'm going to be putting my y variable here first and putting my x variable second. The y goes first because the graph opens up and down in the y direction. The next thing I'll need to do is put in the coordinates of the center of my hyperbola, which happen to be at 3, 2. Since 3 is the x coordinate, I will put that with the x, and 2 is the y coordinate. I'll put that with the y. And then the next thing I need to do is count the distance between the center and the vertex, which appears to be 2 units. And so since it's 2 units in the y direction, I will take and square that. And I'm going to write 4 down below the y because that's 2 squared. The next thing I'll do is I will find the distance along the conjugate axis from the center to its endpoint, which is a distance of 3. That's half of the conjugate axis. And that distance of 3 gets squared, and so 3 squared turns into 9, and so I'll have a 9 underneath my x. And there you go. We have our equation for our hyperbola. In the next example, we've got they want us to write an equation of a hyperbola that has 2 foci at -4, 2, and 2, 2. And then it has vertices at -3, 2, and 1, 2. And so that would be the very first thing I would do, is just plot all of those points. So there they are. I've got my vertices, which are in blue, and I've got my foci, which are in green. And what that allows me to see is where my coordinate of my center will be, which appears to be right there at -1, 2. What this also tells me is which direction my hyperbola will be opening in. Since my vertices are horizontal from each other, that means that I'm going to have a hyperbola that opens side to side, out to the left and out to the right. And so then from there, I can fill in with my variables. I know that my x variable will go first since my hyperbola opens in the x direction. The y variable will go in the second fraction. And then I can put in my center coordinate of -1, 2. -1 for the x coordinate will change this into a +1. And the 2 for the y coordinate, we'll put a 2 here. And now I can find the distance between my vertex and my center, which appears to be 2 units. And so if I were to square that, I would get a 4 underneath my x variable. And now the trouble is that I don't have a conjugate axis length in the vertical direction. It doesn't tell me anything about that. So I need to use my knowledge of the hyperbola and how the conjugate axis and the foci and the vertices are all related with the Pythagorean theorem. And this is how they're related. We've got this distance of 2 between the vertex and the center. We've got an unknown distance, which I will draw here, going vertically in orange. And then we've got another distance that I know, which is 3. And how do I know this is 3? I know it's 3 because the distance from the center out to my foci is 3. So 3 to the left or 3 to the right will take me to either one of my focal points. And so because of that distance, I know the distance along my hypotenuse. So once I know all of that, then I can find the missing side length, which will be useful in my equation. So I'll use the Pythagorean theorem to solve for x. And I actually won't finish solving for x. I'll stop right here. X squared is equal to 5, and I could solve for x by taking the square root of 5, but in the end what I'm going to want to do is take and square that amount anyway, so I want that squared amount of 5, and I'm just going to keep that underneath my y variable. And that's it for that equation. Finally, we want to write an equation of a hyperbola in standard form. And we may just skip the finding of the center, foci, and asymptotes, just because our focus will be just to write it in its standard form. So here's the equation. We start out like this, and with a hyperbola and an ellipse, our goal is to keep all of the variables on one side and move any constants to the other, which is different than when we deal with a parabola, where we want one variable all on one side, other variable on the other. And so the very first thing we would do is we would add 55 to both sides of this, and that would get all of the variables on one side and the constants on the other. And so now what we want to do is we have an equation that looks like this, and we will want to factor the 9 from the x squared and the negative 4 from the y squared, and that's the trickiest part of all of this. And so when we do that, what most people forget is that when you divide by a negative 4, your negative 40 is going to turn into a positive 10. Easy mistake to make. I make it all the time when I'm not paying attention, so you got to be very, very cautious when you factor a negative. And so once we do that, then what we can do is we can complete the square. And so that's the reason why we left a little bit of space in there, is that we need to take this negative 6 and we need to divide it by 2. And we need to square the whole thing. And so that'll turn into negative 3 squared. And negative 3 squared becomes 9. So I will add a 9 to the parentheses. And what you have to remember is that when I add a 9 to the parentheses, I also have to add a 9 to the other side. The trouble is that this 9 is in parentheses and it's getting multiplied by another 9. And so really what I'm doing is I'm adding 81. I'm going to write it on this side as plus 9 times the 9 that is in parentheses, just so we know where that came from. And hopefully that looks alright. The next thing we'll want to do is we'll want to take half of this positive 10. So we'll divide it by 2. And then we will take and we will square all of that. So that would become 5 squared. We will add that in at the end here, which will be adding 25. And once we add 25 to this side, we have to remember to add to the other side. Again, since we added inside of parentheses, we have to remember to multiply the number that's outside of parentheses, and don't forget that it's a negative 4. So we're actually subtracting 4 multiplied by the 25 that's inside the parentheses. And once we do that, then we're going to get the next step in all of this, which is 9 times x minus 3 squared, because that's what you'll get if you factor x squared minus 6x plus 9. You'll get negative or minus 4 times y plus 5 squared, which is what you'll get from factoring this y squared plus 10y plus 25. And if you add together 55 plus 81 and subtract 100, you're going to end up with 36. And so now we don't want the 36 here, we want a 1 there. So our final step is to divide by 36 in all of these fractions, and then if we simplify our fractions, 9/36 turns into 1/4, 4/36 turns into 1/9, and so our final answer is going to be the equation that looks like this and doesn't want to appear on the screen for you. There we go. So it's going to end up looking like this, and then you'll be able to know where your center is. It'll be at 3, negative 5. You'll know the transverse axis would be the square root of 4, which is 2. The conjugate axis, that's only half of the transverse axis. That would be the distance from the center to your vertex. The square root of 9 would give you 3, which is half of the conjugate axis. That would be in the y direction because the y variable is above it. And just in case this would be something that would be useful, we'll just try and draw a quick sketch of it right here. We want to go to 3 and negative 5 for our center. And then we want a conjugate axis that goes out 2, so that's going to be a vertex out here. and a vertex back here. We want our conjugate axis to go up 3 and to go down 3. And then from there, what we should do is we should draw a box around all of these points. So just in dashed lines all the way through. And the reason why we do this is because we want to draw our asymptotes using a very nice slope. So our slope is up 3 and to the right by 2. So if we were to continue that throughout, up 3 and to the right by 2, that'd be a point. Up 3 and to the right 2. And then the same thing on this side, up 3 but to the left 2 should follow that same pattern. And so we've got a few points here that will give us our asymptotes. And we can draw them through the corner of our box and through the center of our box as best as we can with a mouse. And they'll look something like this. And all this does is it gives us kind of this framework to kind of make sure that we're going to keep our graph inside of that. So we'll graph out this way and we'll go all over the place trying to keep inside of those lines. Remember, I'm doing this with a mouse, so it's not going to look pretty. And there you go. You'll have a hyperbola that looks much smoother than that, but that's all the information you should need. So hopefully that gets you a start on what to do for hyperbolas, finding equations, giving some information, putting them in their standard form. What you should try right now is this assignment, and hopefully that will go okay. If you need textbooks, they're in the cabinet, and hopefully you'll be able to find everything you need. If you have questions, send me an email.